Hello everyone. In this video we will discuss uh, useful methods to define large arrays in MATLAB. And the first useful method we will discuss is the so-called colon operator. So the colon operator. So the way it works is that you give a starting point for the array, an increment, and then an end point for the array. So for example, I can define an array x equals starting from 0 with an increment of 2 ending at 10, and that will give me the array 0, 2, 4, 6 all the way to 10. Another possibility here is that if we do not define the increment, like if I delete the 2, then the default increment is 1. So if we hit enter here, the array x will start from 0, 1, 2, 3 all the way to 10 with an increment of 1. So the default increment is 1. Another useful thing to know is that this increment is allowed to be a real number. For example, I can define a really large array by starting from 0 with an increment of 0.1 all the way to 10. And if I hit enter here, you see this large array starting from 0, moving with an increment of 0.1, so 0.1, 0.2, 0.3, and then the last element is 10, and the size of this array or the length of this array is 101 because it contains 101 elements. In fact, I can do this here, length of x is 101. You can estimate the size of this array by a simple calculation. It's the end minus the start divided by the increment plus 1, provided that you take the integer value of this. So in the case that we just analyzed, it's 10 minus 0 divided by uh, 0.1 and then plus 1. So that gives us 100 plus 1, which is 101. Another possibility for the increment is that it could be a negative number provided that the starting point is larger than the end. So for example, let's show a case here. I can say that x equals starting from 10 with an increment of negative 2 all the way to 0. And if I do this, I will get an array that contains 10, 8, 6, 4 all the way to 0. So negative increments are also allowed. You might also be careful, you have to be careful a little bit when the end point in particular is not divisible by the increment. So let's actually take an example. Suppose x, clear first, suppose x starts from 0 with an increment of 2, it ends at 7. So that raises the question, what are the elements in the array? So let's start systematically. 0 is part of the array, 2 is part of the array, 4 is part of the array, 6 is part of the array, but then how about 8? So 8 is supposed to be the next element based on the increment, but notice that 8 exceeds the end point, so 8 will not be part of this array, and it's going to stop at 6. So let's actually test this here. It's consistent with what we described. All right, so that's the colon operator. There is another very useful way to define arrays when you know the number of points that you need, and that's using the linspace function. Suppose, and how does it work? Suppose you were asked to generate an array that starts from maybe 0 all to the way to 4, and suppose that you need 200 points. So you need 200 points between 0 and 4, including 0 and 4. So then you hit enter and you get an evenly spaced or regularly spaced an array starting from 0 with an increment which you can, of course, you can calculate. But if the increment is like a complicated real number and you know the number of points, it's actually easier to use the linspace operator as we did here. So yeah, so these are all the possibilities or the best possibilities to generate large arrays using the linspace and using the colon operator. We will learn other methods later. So let's take quick exercises on this. Suppose you want to create an array X. Of course, as always, I would recommend that you try these exercises and then compare your solution with our solution here. Suppose you want to create an array X that contains 100 regularly spaced values starting at 5 and ending at 28. So in this case, we know the number of points. So then linspace is the best option here when you know the number of points rather than the increment. It's going to be linspace starting from 5, ending at 28 with 100 points in total, including 5 and 28. And that gives you this array. Of course, its length is 100 because you designed it in this way. All right, so this is the array X. I was also asked to calculate an array Y or create an array Y that contains a regular spacing that has a regular spacing of 0.2 starting from 2 and ending at 14. Well, this is 2, that's the start, the increment of 0.2, and the end is at 14. So this has 61 elements. Of course, we could have also estimated the length of this array using the rule that we just discussed. It's the end minus the start divided by the increment plus 1. And that's basically 12 over 0.2 plus 1. That's 60 plus 1, and that gives you the 61 elements. It's always good to have some idea of the size of the array while you are trying to generate it. Of course, you can always use the length, but these estimations, in my opinion, give some sort of a deeper of understanding of these arrays. So let's do CLC here. The other question is, let's clear. The other question is, suppose we have an array written in this way, so x equal starting from 0, increment of 0.1, all the way to 2 times pi. The question is, how many elements are there? Of course, we can do length. But before we do length, it's better to do estimation. So let's see, how much is 2 pi? 2 pi is about 6.3. Approximately. So we can say that it is the end, so which is 6.3, or no, it's not 6.3, it's 6.28. 6.28 minus the beginning, which is 0, divided by the increment plus 1. But then notice that 6.28 divided by 0.1 is 62 something. So you need to truncate that fraction and you end up with the real number, which is only 62. So 62 plus 1, that gives you 63 elements. So because this starts at 0 and it doesn't end at 2 pi really, it ends at 6.2 because the next element, so it's like 0, 0.1, 0.2, 0.3, it ends at 6.2. It does not actually jump to 6.3. So this is not part of the array. Let's confirm this by calculating length of x. Oops, what did we do here? Yeah, we changed things because we calculated this 2 pi. So maybe let's clear here. Let's define x again. So it is starting from 0. Oh, yeah, because of this. This has to be a comma. Let's correct this and calculate length of x. 63. Let's actually print x. So as you see, it stops at 6.2 and it does not print 6.3. It's not part of the array. So that's why there are only 63 elements rather than 64 elements. So in summary, we gave you two options to define large arrays in MATLAB: the colon operator and the linspace. Colon is preferred when you know the increment. Linspace is preferred when you know the number of points. You can use both of them to generate large arrays which are hard to enter by hand. Thank you so much and see you in another video.